So, good evening, everyone, and this is lecture number 11 in uh, your topic, ray optics, and we were dealing with curved mirrors. We had done some questions in the previous class. We will try to solve some more questions in this class. I have gone through the material that you have been sent. We will do questions from that as well. Don't worry, I will send you extra questions as well for practice. So I'll just talk to the office people and do that. Okay. So we are still there in the last class.
Sir,
Yes, beta.
you said you'll be providing us some sheet, but we did not get yet.
Just give me a day or two. In a day or two, I would be giving you some sheets which would be pertaining to what we are supposed to do in the examination also. I'll send you those sheets. Okay, so I was just waiting for the material to come so that I can have a look at what is there in the material and what questions are there and what questions are not there. So I just had a look at them. I will send you my sheets, and what you will try and do is concentrate on those sheets that I sent you. Okay, you will try to do those sheets that I have sent you. That will be important, and I will be giving you homework from that sheet as well. Okay, done? So
Yes, sir.
I'll send you those sheets, and I will be giving homework from those sheets. Anyways, we were discussing problems in the last class, and we had discussed some previous year problems as well. We had seen what types of problem are coming in the exam these days. Okay, we will solve 2 or 3 more problems, and that will give us an idea of what you can expect in the examination hall, right? So let us go and solve this problem, and once we are done with these problems, I think we would be done with this particular topic, reflection, as well. And from the next class we can probably move on to the next topic, which is what? Which is refraction. I just want to do a couple of uh, problems from here so that the entire this thing is covered. So this is the first problem that we are going to do, and there is a particular reason why we are doing this problem. So I will tell you the reason once we start with the problem. So this is problem number 1, and you don't have to write the entire problem in words. You can just note down the important points as question. What are the important points of this question? The focal length of a concave mirror is 30 centimeters. So you can just say mirror is concave, focal length is 30. Will it be plus 30? Will it be minus 30?
Minus 30.
Minus 30. Now you just the only information given in the question is focal length is minus 30. Find the position of the object. So what you have to find out is the value of u. Do we understand this? In front of the mirror, so it is not back of the mirror. If the object is in front of the mirror, what does that mean? Is it a real object or is it a virtual object? The object is in front of the mirror. What does that mean? Is it a real object? It is a virtual object. Yes or no? Do we understand
Real
this?
object.
It's a real object. Okay, well done. So these are the things that you must remember. Find the position of the object in front of the mirror so that the image is 3 times that of the object. So this is the question, and we need an answer, and there is a very specific reason why this question is given. So what is the answer for this question? How are you going to solve it? Remember, I have only told you 3 formulae. 99.99% of the question will be coming based on that 3 formulae. One was the formula of F and R. The other one was the formula of 1 by V and 1 by U. The third was the formula of magnification. Yes or no? Do we remember this?
Yes, sir.
Based on only those three formulae, you are going to get a question. So here is the question. Can you tell me what is the answer? And I'll give you a minute. And I want everyone to try the question. I can see someone, I can see boys sitting and just looking at the whiteboard. Please solve the question. Remember, technology has developed a lot, but still there is no technology uh, that will make the question solve automatically on the board if you are looking at it. So no matter how much you look, the question is not going to get solved automatically on the board. The only way question is going to be solved, my dear friends, is by when you try it. Now is the time for you to try it and tell me what is the answer that you are getting. Remember, the questions that we might be doing in the class, please mark my words, the question that we might be doing in the class may be more difficult, much more difficult, I must add, than the question that will eventually come in your exam, that is NEET. The question coming in NEET would be a lot easier, and whatever questions we are doing may be a lot difficult. This is probably one of the more difficult questions that you can expect. So you don't have to do any question which is more difficult than the ones that we are doing in the class. I hope you understand this. That is what I call smart work. You must understand what type of questions are coming, what type of questions you should be doing. Doing any random question is not going to solve the purpose. Do we understand this, my dear friends? So I pick questions which have relevance and which are more likely to come rather than questions which are fictitious. Yes, anyone with an answer for this? You got the answer? No? That means no one has studied. Did you read? Did you go through the notes at home before coming to the class? How many of you read the? How many of you read the note before coming to the class today? Please raise your hands. Only Abhiram did. Okay, you did this. Then what is the problem? Tell me. What is the problem? Why are you not able to solve this question? First, tell me that. Is this a question that we have not done? Okay, Abhiram says he is calculating. What about the others? Abhiram says he is calculating. Is this calculation? I think it's 20 centimeters, sir. You have got the value of u, Abhiram. That is correct. But is it plus 20 or is it minus 20 that you are getting? Rest of rest of the class is, I don't know, lost somewhere. Have we done question like this before? Yes or no? No? See, we have done, as far as I remember, and I can show it to you, how many questions of the similar type we have done. Let us start counting. This is question number 1. Similar type we have done. Question number 1. One question. Question number 2. Similar type we have done. No one recollects it. This is from your same class, beta. Question number 3. Similar type. Same question. Last class. Three questions on similar type we have done. That is what I can count. and still we are not able to do a question that comes on similar lines. Tell me what is the problem that everyone is facing. Do not look at the whiteboard. It's not going to get solved by looking at the whiteboard like this. This photograph only looks good in the image of Tare Zameen Ke when Amir Khan is watching that stupid board. But we are not Amir Khan. And we are not that child who has a problem in understanding things. If we have a problem, you must let me know. That's how we have a problem. So we can remedy that problem. Sitting in front of the board like this doesn't look good. Doesn't do anything. Just tell me, what is that you can't calculate? Arey, speak up. Tell me, what are you calculating? It's been 10 minutes. What are you calculating? Are you applying quantum physics here? Everyone is doing something. What something are you doing? Tell me. Your mic is not working? Is that so? Please say what you are doing. I mean, everyone is doing something. I can see that. That's good. But what are you doing? What is the problem? Mic is not there, I guess. The mic is a problem. Understand, the mic is a problem. Anyway, the reason that this question was given was, can you tell me which formula are you going to do? Which formula are you going to apply? Which formula? If you remember these formulae, I think I had given to you in the last class all the formulae together. Do you remember which formula you need to apply here?
M equal to F by F minus U.
Well done. That is the formula that you need to apply, and just go on back to the class and see that is the only formula that has been highlighted there in yellow. So you can see it. That is the only formula you need to apply. So how long will you take to apply this formula? It should not take much. It should not take much to apply this formula, right? Well, anyone understands this? Please
Yes,
raise your
sir.
hands. Yes, beta. Tell me, what's the problem? I must understand the problem. Then only we can work on the solution. If I don't understand the problem, we cannot find the solution. Do we understand that we have to apply this formula? Yes or no?
Yes, sir.
Yes, sir.
What about the guys in the class? Do we understand this? They're
Yes,
still writing
sir.
something. No, the other class. The class that probably does not have a mic and only has students. They're only looking at the whiteboard and doing nothing. Do we understand this, beta? That this is the formula we need to apply? Please raise your hands.
Yes, sir.
Yes, sir.
I can't see you. Yes, we understand this. Okay. Then we just need to apply it. Nothing else. We just need to apply it and we will get our answer. Now, the problem is, the real problem in this question was not which formula needs to be applied. The real problem in this question was the object was given as real, but there was nothing said about the image. We did not know what type of image was there. So the real question was this: what kind of image would be there for a real object? What kind of image can a concave mirror form for a real object? Yes, beta.
Real or virtual?
It can form real as well as virtual. Now, since it can form real as well as virtual image, my dear friends, therefore we have these two things coming. These are the two diagrams that are possible. This one is for a real image. It is forming a real image, and this one is it forming a virtual image. Now, if the image is real, and that was the point here, the magnification is negative. In this case, magnification is 3 times. Therefore, in this case, magnification would be -3. If the image is virtual, the magnification is positive. In this case, the magnification would be +3. That was the point of this question, why this question was given, my dear friends. So you will have two answers depending on whether the image is real or the image is virtual. Do we understand this, my dear friends?
Yes, sir.
Yes, sir.
That was the real question, my dear. That was the real question, my dear. Whether the image is real or the image is virtual. That is what you have to understand, my dear friends. I did not know that you have forgotten the formula. That is very sad. Had you forgotten the formula for magnification, my dear friends?
No, sir. I did
Then
No,
not.
sir.
why could not you give me the answer? I am disheartened here. I mean, we are doing so much of hard work. You, especially, you are putting in such a amount of hard work, and still, if we are not able to solve simple questions, beta, it breaks my heart. So, if the image is real, beta, magnification is -3. If the image is virtual, my dear friends, the magnification is +3. Then we simply had to apply the formula, dear. Magnification, which is -3, that will be equal to f upon f minus u. You know the value of f. How much is the value of f, my dear? F was given as -30. You just had to put the value of f as -30, my dear friends, and from there you could have calculated the value of u. If you tell me, sir, we are having problems in calculations, I can still understand, because you are from the bio side. I can understand that you might have some difficulty in calculating. I can understand that. So tell me, was there a difficulty in calculating or was there a difficulty in understanding the problem? Where was the
Calculating.
difficulty? Understand.
Calculating, sir.
Calculating, sir.
Calculating. Okay. So what I would suggest is I will send you a series of questions which will have a lot of questions of this type that will help you in solving them. And you can make simple questions like this. You know what type of calculation is employed here. Something is in the numerator, something is on the left hand side, then we have a numerator and a denominator. You can use different values and find out. In some cases you might have to find the value of f, in some cases you might have to find the value of u. Now I can also make a formula for f and u from this, but again, if I make so many formulae, it will be very difficult for you to learn them, and that is why I have only made those formulae which are which are just required. They are very essential, and this formula that you see here, f upon f minus u, it is very essential that you remember this. I can make two more formulas from here. This is magnification in terms of f and u. I can get the formula of u in terms of m and f. I can get the formula of f in terms of m and u, but that is just going to make the life complicated for you, nothing else. And that is why I have not given you those formulae. I have given you the formula which you must remember, and after that you can calculate. Do you understand how it is done now? Now what is difference between the first case and the second case? In the second case, what is going to happen, my dear friends, is that this magnification will become +3. +3 will be equal to f upon f minus u. Again the same calculation will come. The only thing that has changed is on the left hand side, now we have +3. Previously we had -3, and therefore the entire answer changes. If I understand clearly, if I've done my calculation correct, u in this case is coming as -40. Can anyone confirm it? And u in this case is coming as -20. Can anyone confirm the answers, please, for me? Are these the answers coming? Abhiram says that he did the second way, sir. Remember, sir, that is the reason why this question was given to you. Now remember, in NEET, Yes, you took it as +3. Why did you take it as +3? It was not given that it's a virtual image. Now remember, in NEET, you will not get a question which will have two options, but then it will be mentioned whether the image is real or the image is virtual. I just gave you this question so that you don't forget that for a real object, a concave mirror can produce both image. So you will have to see what type of image is getting formed, because if the image is real, the answer is different. If the image is virtual, the answer is different. I guess everyone has noted this down, yes or no? Yes?
Sir,
No? Yes, beta.
how we got magnification as -3 and plus?
How did we get magnification as -3? Have you read the question, beta? Please read the question for me. Please read. You can read the question now. Please read it for me. I'm waiting, bacha. Can you read the question for me, please?
Focal length of a concave mirror is 30 centimeters.
Where we have used this? Do you see where we have used this? Yes or no? Okay, go ahead. Go ahead. We have used the focal length here. Yes, go ahead.
Find the position of the object in front of the mirror.
What we have to find out here? The value of? What we have to find out here? The value of?
U.
Okay. Go ahead.
So that the image is 3 times the size of the object.
What does the last line mean? What does this line mean, beta? What does this line mean? Do you understand the meaning of this line?
Yes, sir.
V is
Image-
3 times the size of the object.
So, which value is given here? In terms of things that we know, which value is given here? Image is 3 times the size of the object. How do
Okay,
you
sir, got it.
how do you relate the size of the object with the size of the image, my dear friend? Size of the image, height of the image, length of the image, area of the image divided by size of the object, length of the object, area of the object. That is magnification, no? So they have given the value of magnification, that the magnification is 3. Yes or no?
Yes, sir.
Do we understand this, everyone in the class?
Yes,
Please raise
sir.
your hands.
Yes, sir.
So if you don't read the question carefully, my dear friends, then you will land up in trouble. So here it is given, the magnification is plus or minus 3. Why I'm writing two values? Because it can be real image with negative magnification and virtual image with positive magnification. Everyone has a doubt still left? Please tell me. Anything that is still left in your head that is troubling you, please let me know, my dear friends. Please let me know. Shall we move on to the next question?
Yes, sir.
Yes, sir.
Everyone, the other class.
Yes, sir.
One class has girls, the other class has boys. The boys class. Are we
Yes,
ready?
sir. Sir, am I audible?
Beta, you are audible, but where you're not visible. Where are you? Where are you? Oh, at the back, at the back. Oh, sorry. I missed it. I mean, you were looking so small there, na? So I missed it. Okay, chalo. And now I hope that this question, and incidentally, I think this is a question from your sheet, your module. And I guess this is question number 17 from your module. So you can have a look at question number 17 from your module if I'm not wrong. This is a solved example that we are doing. Anyways, doesn't matter. For me, it is question number 2. So that was question number 1. An extended object is placed perpendicular to the principal axis of a concave mirror of radius of curvature 20 centimeters at a distance of 15 centimeters from the pole. Find the lateral magnification. It is as simple as it gets, my dear friends. As simple as it gets. As simple as it gets. And I wait patiently for your answers, because these are the type of question, my dear friend, that you are going to find eventually appearing in your NEET ka paper. So I what? I wait for your answer. Can I have your answers, my dear friends? Yes, yes. Yes, my dear. Answer, please. This is a simple question, dear. Okay, so how are we supposed to do this? Anyone? Which formula do you need to apply? What all things are given to you? Mirror is given as concave. Radius of curvature is given as 20. From there you can calculate the focal length. The object is placed at a distance of 15 centimeters from the pole. So the value of u is given. You have to calculate the lateral magnification. It is as simple as it gets, my dear friends. Please let me know the answer. It's a straightforward question. Who tells me the answer first? Do we know which formula we need to apply? Abhinam knows it. What about the rest? Which formula we need to apply?
F by F minus U.
Just apply it and get your answers. The formula that we need to apply.
So wait a minute, we will try.
Yes, okay, I'm waiting. I'm waiting. I know that you might take some time in calculating the values. Calculation may be a problem. I wait patiently.
So -2.
-2 is the magnification. That is absolutely correct, my dear friend. That is correct. It is as simple as this. This is the formula that we need to apply. Do we understand this formula, everyone? Please raise your hands.
Yes, sir.
We just put the values here. So, what is the value of f? Remember, radius of curvature.
-10.
Radius of curvature is given as 420. So focal length becomes 10. It is a concave mirror, so it is -10. If you put +10, well, everything will go here and there. So the focal length is -10, remember, my dear friends, divided by, in the denominator again I have to put the focal length -10, minus, just tell me the value of u. Object is real, dear, so u has to be negative. It is at a distance of
-15.
yes, -15. Well done. You just calculate this small fraction and you will get the answer. You will get the value of magnification as -2, minus indicating that the image is real. How many of you got this? Please raise your hands. Nabiram got this answer. 2 girls got this answer. No one from the boy community got the answer. Yes, 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 we are there, we are there. Boys are still alive and kicking. Even though they have been beaten very shamefully by the girls, still hope remains. When I feel very happy when boys get beaten. Because the only thing that I like about boys is they getting beaten. And I don't like boys winning. Boys should never win. Are we ready for the third question?
Yes, sir.
Give, sir.
Let's see who does this. Again, I think this is a question from your sheet, from your study material. A person looks into a spherical mirror. The size of the image of his face, obviously, is looking at his face, is twice the actual size of his face. Oh, twice. His face is at a distance of 20 centimeters. Who is calling? Why does it happen that in your class only people start calling? Who is missing whom? Your mom and dad missing you? No, I don't think so. Find the nature of the radius of curvature of the mirror, my dear friends. What type of mirror would be there? I first ask you, what type of mirror would be there? Will it be a concave mirror or a convex mirror? Concave mirror or convex mirror?
Convex mirror, sir.
Convex mirror. And what makes you believe that it will be a convex mirror? Why not a concave?
Huh?
Object is real.
Twice the actual size.
Twice. Yes, that is the
Enlarged image.
enlarged image. Then, my dear friend, tell me, can a convex mirror for a real object, can it form an enlarged image? Now that is where the power of the brain and the power of memory will come, and I know that you don't remember it.
No, sir.
Do you remember it? Everything is there in
Concave mirror, sir.
in your notes. And I've gone back and I've just shown you the snapshot of this. Important point: convex mirror for real object. Convex mirror can only form virtual image whose magnification is less than 1, my dear friend. Less than 1. Less than 1. Less than 1. It cannot form enlarged virtual image, and if I can see my image in a mirror, it has to be virtual because real image will be on the same side. I won't be able to see. It has to be a virtual image. So the mirror has to be concave, my dear friends. And for a concave mirror, again look at your notes. The magnification for a virtual image is always greater than 1. So from here we can conclude that the mirror has to be concave and the image is virtual. Then only you can see your image when your image is virtual, otherwise you cannot see. Do we understand this? That is the reason I have done this question. Do we understand this?
Yes, sir.
How many of you have actually written the notes that I've been shouting for the last 10 classes? Has anyone actually written notes? Girls have definitely written notes. Boys, I don't think I have written any note, and that is the reason that you see beta. In the class, while the class is going on, everything looks very simple, that you can remember them. Please note them down. Why I am showing you back, why I am showing you back, why I am showing you with every question, because every question has to be done from what we have already discussed. can recollect them, you will be able to solve the question very, very nicely. Let us now solve this question together, the power of all of us together. So now we realize that the image is virtual. Do we realize this? Please raise your hand and tell me that we realize that the image is virtual.
Yes, sir.
Image is virtual, that means magnification is positive and it is given the size of the image is twice. So we understand that the magnification is +2. Yes or no?
Yes, sir.
That's it. Magnification is +2, my dear friends. And it is also given that the face is at a distance of 20 centimeters. So you also know the value of u, my dear friends. Oops, wrong color. I hate wrong colors. The value of u is given as -20. From there you can calculate the value of f. From there you can calculate the value of r. Please, please, please get me the value of f and r. I would be very happy if you can give me the value of f and r.
Sir, 80.
Well done. 80. Radius of curvature is 80 centimeter. I must say correctly, it must be -80 centimeter because this gentleman is a concave surface. Do we understand this, everyone? Yes or no? No, yes. Which formula we need to apply again? The famous formula, f is equal to m is equal to f upon f minus u. The value of m, as you can see, is +2. The value of u, as you can see, is -20. From here, my dear friends, you can calculate the value of f, and the value of f that is going to come, I think, will be -40 centimeters. Once you get the value of f as -40, you should get the value of radius of curvature as -80. Do you understand this? Yes or no?
Yes, sir.
Yes, sir.
Anyone
We
understand?
got. Yes, sir. We got.
Okay. Shall I move on to the next question, my dear friends?
Yes, sir.
Yes, sir.
Are you confident that you will be able to solve this? Remember, all the questions are pretty damn simple, my dear friends. All questions are pretty damn simple. So now what I'll do is I'll give you two more formulae, and these two formulae are going to come as it is. If a question comes on this, so write the next heading here, and the next heading here is power of a mirror. Power of a mirror. Now I can see some of you wearing glasses, so you might be having a better idea of what do you understand by a power. You are not wearing mirrors, you are wearing lenses, so we'll come to lenses as well. Can anyone tell me what is power of a mirror? Take the example of your lenses. The same thing that the same thing for lenses, the same thing is for mirror. What does power of a mirror tell us? Anyone? Any guess? See, no question, no answer is right or wrong. I just want to understand your point of view. I can see a lot of boys wearing glasses and some girls as well. What do you understand by power?
Sir, I think magnification.
Yes, it is a sort of a magnification. It tells us, whether we will get to these defects of eyes as well. Short-sightedness, long-sightedness. I'll give you a formula. You can say power is somehow related to magnification. So we'll have two types of power, right? Positive power or negative power. Do we understand this?
Yes, sir.
What do you understand by negative power and what do you understand by a positive power? For a mirror or a lens, it's the same thing. Let us first write the power ka formula for a mirror. Power ka formula for a mirror is -1 by f. Remember, this f has to be in meters. If this F is in meters, then the answer for power will always come in diopters. Have you heard this? Have you heard this unit diopters? Yes or no? No, yes.
Yes, sir.
If the focal length is in centimeters, my dear friend, you convert it into meters and then put it in this formula, or you can have this formula minus 100 by F of what is this? Minus 100 upon focal length in centimeters. If you put it, this will give you the power of the device in diopters. Now this power, as you can see, is negative of the focal length of the mirror. So for a concave mirror, will the power be positive or negative? Please tell me. For a concave mirror, power would be negative or positive?
Positive, sir.
Well done, my dear friend. For a convex mirror, will the power be
Negative.
positive or negative?
Negative.
It is negative. Now remember, beta, whenever we are talking about positive power, again wrong color, why I mess up with colors? Whenever we are talking about positive power, which is now in yellow, positive power is always for converging. Positive powers means it is a converging device. It is going to converge the rays of light. Therefore, we call concave mirror as converging mirror. Do we understand this?
Yes, sir.
Power
Yes,
positive
sir.
means the device is converging. Then if I ask the ulta of this, power negative, what does that mean?
Diverging.
Yes, my dear friends, if power is negative, that means your device is diverging. Converging and diverging. Converging and diverging. Now, if you have a lens and your power is positive, you are wearing converging lenses. It is negative, you are wearing diverging lenses. Do we understand this?
Yes, sir.
Okay, sir. Well done, sir. Then that takes us to probably the last portion of this particular topic, which is reflection, and that is Newton. Newton comes again. Newton laws of motion. Newton's laws of gravitation, Newton's laws of cooling. Newton has been everywhere. Newton's formula. Newton's formula. Has anyone heard about this gentleman? No, not Newton. Has anyone heard about Newton's formula in optics? Yes or no? No, yes.
No, sir.
No, sir.
Okay, now you are not going to see any question on Newton's formula, that is I can assure you, but I have seen questions coming in NEET where they ask you what will happen if this happens. So this is your diagram which is going to explain us what is Newton's formula. Now what do you see here, my dear friends, is a concave mirror, no problems. You see here is an object, no problem. Oh, you see here is an image, no problem. The distance of the object is u, the distance of the image is v. Do we all understand this? We have been using this, yes or no?
Yes, sir.
The focal length of the mirror is f, we all know this. Now remember, according to our sign convention, all the distances are measured from the pole P of the mirror. Yes or no? No, yes.
Yes, sir.
All the distances are measured from the pole P of the mirror. But, if instead of pole of the mirror, if the distances are measured from the focus, from the focus, my dear friends, And as you can see, x1 is the distance of object from the focus, and x2 is the distance of the image from the focus. Do we all see this? Can I have raise hand that we see this? So instead of distances being measured from the pole, my dear friends, if the distances are measured from the focus, then the formula of mirrors is known as Newton's formula. And you would be surprised to see Newton formula looks very extravagant. x1 into x2 is equal to f squared. And this formula is known as Newton's formula. Here the distances are measured from the focus of the mirror, and the formula looks like this. Don't worry where this formula comes from. It comes from the original formula. 1 by v plus 1 by u is 1 by f. Instead of u, you put the value of o in terms of x, and you get your answer. Do we understand this, my dear friends?
Yes, sir.
Can I have raise hands from everyone? Okay, great. Now remember, there are some points that will come as direct questions in your exam, and you have noted this down, the diagram. Can I move on to the next point? Quick point.
Yes, sir.
Yes,
Okay.
sir.
And I will not waste any time in putting this, and I'll just put this here in front of you. Now I've seen questions coming on this, so you just note down this point, and this point is self-explanatory, a very important point. Remember, there are questions where what happens is you put a lens inside water or inside some other liquid, and you find that the focal length of the lens may change. It changes. A converging lens can even become a diverging lens. A diverging lens can become a converging lens. But that happens only for lens. It does not happen for a mirror, my dear friends. So, a mirror, the focal length of the mirror always remains same whatever you do. You put it inside water, focal length remains same. You put it in air, focal length remains same. You put it in alcohol, the focal length remains same. You put it in a soft drink, a bottle, the focal length of the lens of the mirror, my dear friends, does not depend on the medium surrounding it. Focal length of the mirror is r by 2. It only depends on the radius and is independent of wavelength of light, refractive index. It does not depend on which light is falling on it, where this mirror is put. It is inside water, outside water, doesn't matter. This is a very important point that you must remember. I hope you have noted this down. Yes or no? No, yes.
Yes, sir.
Questions on this has come previously. So please note this point so that if they come again, my dear friends, we are ready for these questions.
Done, sir.
Done, sir. Then there is one more point which I would like you to note down. Remember, these points are going to come as direct questions, my dear friends. You just have to remember these points. The next point, and it comes on your screen right away. I have seen a large number of questions which comes on what will happen if you blacken or you block a part of a mirror or a part of a lens. So this is the point for part of a mirror. Every part of the mirror forms a complete image. If a part of mirror is obstructed, full image will be formed, but the intensity of the image will be reduced. So as you can see here, my dear friends, what has been done is there is an object here. You see the object here? This object is placed in front of a mirror, and what we have done is we have blocked this part of the mirror. Do you see this? This part of the mirror has been blocked. But no matter if you block any part of the mirror, you can still see a complete image being formed. The only problem is intensity or the brightness or the clarity of the image will be reduced, but it will not happen. Since I have covered half of the mirror, only half of the image will be formed and the rest half will not be formed. You can check it. You can check it with your mirror. If you cover one half, still you will have the complete image being formed. Do we understand this?
Yes, sir.
Yes,
So these
sir.
are the points that you must remember. I've covered everything that can possibly come in your NEET exam. You don't need to do anything else. The only thing you might require and you should require and you require to do is to practice question. I'll be sending you sheets for that. Practice from those sheets and stay happy. In the next class, we'll be moving ahead. The next topic, refraction. And now we are done with reflection. We will now move on to refraction. And refraction is as fascinating as it gets. Reflection is smaller, refraction is bigger, so it will take probably more time to cover this. If you have any doubts, please ask. Else, it's a wrap from my end. And please, when you come to the class, in the next class, please study before coming. Take care. Bye bye.